Hi everyone, what's up? Welcome back to my financial mathematics and SMFM preparation tutorial. Today lesson I'll be talking about continuous annuities. So first I'm gonna introduce continuous annuities. Then I'm gonna talk about double dots cancel, some result in interest varies problems. So let's get started. To understand continuous annuities, we first start off with annuity AN with top script M. So remember on the last lesson, an annuity AN with top script M means this annuity lasts N years, make N years duration. And in each year, we are going to make M payments. For example, AN is annuity immediate with which is um, make in one in end year, and every year we pay $1. AN with top script 2 is an annuity that make over an end year period, but in a year we make payment twice. So in each payment we make we pay one half. So in a year we pay totally $1. And similarly for these annuities. So pay attention to the last one. AN with the top script M to the 6. That means this annuity lasts in years, and in a year we make up to 10 to the 6 payments. So roughly every 30 seconds we have to make a payment. So for this annuities, we have some remarks. Payments are made over N years period. So N years mean the payments are made over N years period, and the total payment of each year is 1. And in 1 year, $1 is payable in M place installments. Its payment is 1 over M. So the next step, we are going to increase M. So imagine what happens as M grows larger and larger. So let's look at this. AN with the top script M is 1 minus V to the N over I to the top script M. I to the top script M is the nominal rate interest. So we are going to consider this limit because we expect M to increase to infinity. We notice that from the first lesson, measurement of interest, I to the top script M is M times 1 minus 1 plus I to the 1 over M. So we are going to substitute this amount into the formula. So limit, we're going to consider the denominator first. So limit when M go to infinity of I to the top script M is limit M go to infinity of 1 minus 1 plus I to the 1 over M, the whole thing divided by 1 over M. So M on the numerator, I flip to the denominator, so it's become 1 over M. And we're going to consider this limit. So this limit is quite complicated. So we're going to use the hospital rules to solve this limit. So limits of I to the top script M when M go to infinity is limit M go to infinity. On the top, when we differentiate the top, we have this is A to the U derivative. So it's become A to the U natural log of U with time U prime. So U here is 1 over M. So 1 over M prime is 1 over M squared. Negative 1 over M squared with negative here, so negative with negative cancel. 1 plus I, then we have A to the U, that is 1 plus I to 1 over M. And U prime is 1 and natural log of A, so we have natural log of 1 plus I over negative 1 over M squared, because 1 over M derivative is negative 1 over M squared. So now we see 1 over m squared and 1 over m squared cancel out. So we have negative 1 plus I to the 1 over m times natural log of 1 plus I. And one thing you need to remember, when m go to infinity, 1 plus I to the 1 over m will go to 0. So this become only natural log of 1 plus I with negative psi in the front. And don't forget, negative natural log of 1 plus I is just delta, the force of interest rate. So we're going to use this into the formula. So limits of this annuity when m go to infinity is basically 1 plus 1 minus v to the n over delta. So here we have two important formulas. The first one, limit of this annuity is 1 minus v to the n over delta. And because when m goes to infinity, we make infinite payment. So this is kind of continuous payment. So we have a new notation with a bar on the top. So a bar n is a continuous annuity that is made in a year, that is made continuously. And remember, 1 minus v to the n over I is an. So we are going to make a connection between the continuous annuity and the regular annuity. So if you multiply I and divide by I, you have the continuous annuity an bar is basically I over delta an. So this is the connection between the relation between continuous annuities and regular annuity. Next, another way to look at continuous annuity is using integration. So the integral form of continuous annuity is we are going to take integral from 0 to n of v to the t dt. So v to the t dt, the antiderivative of v to the t is v to the t over natural log of v, and we take integral from 0 to n. So this integral becomes v to the n minus 1 over natural log of v. So remember, natural log of v is natural log of 1 plus I to the negative 1. So that is negative natural log of 1 plus I. And natural log of 1 plus I is delta. So this is negative delta. And then we are going to flip, switch position of 1 and v to the n to cancel the negative side here. So the continuous annuity that lasts in year is basically 1 minus v to the n over delta. So this is another way to prove the continuous annuities that is made in an n-year period. So that was about continuous annuity. Now we are going to look at a tips that is double dots cancel. So let's consider the following ratio. Here we have the ratio between two annuity dues. The first one is A double dot N and the second one is A double dot P. So using annuity due formulas, we have 1 minus V to the N over D on the numerator, and the denominator is 1 minus V to the P over D. D with D cancel, so we have 1 minus V to the N over 1 minus V to the P, and we want to show the double dots cancel, so we try to manipulate this ratio into the ratio of two immediate annuities. So on the top we divide by I, and at the bottom we divide by I because we want to appear annuity immediates. So the numerator becomes an and the denominator becomes a p. So you see that double dot cancel. So the double dots and the double dots cancel out. And not only the double dots cancel, we also have upper m cancel. So let's look at this annuity. The upper m's cancel mean these two upper m's gonna disappear. So This formula is very easy to prove. On the top, you divide it by I to the top script m, the nominal rate interest. And at the bottom, also divide by the top I to the top script m, so that these two cancel out. Alright, so you have A double dot N over A double dot P. And don't forget double dot cancel, so AN over AP. And if you divide 1 minus A to the N is 1 minus V over 1 minus V to the N over I over 1 minus V to the P over I. So I with I cancel. We try to divide both numerator and denominator by I to the M, the upper M top script. So we have the last formulas. So not only double dots cancel, upper M's also cancel. Next, a short note to remember annuity formulas. So up to now we have finished 4 lessons in annuities, and we have so many formulas to remember before you get into the exam. So how do you memorize them? Even though there are a lot of formulas, but actually there is a tips for you to memorize them. So we have 5 tips to memorize annuity formulas. The first tip is of the present value for level annuities. AN, A double dot N, have the same numerator 1 minus V to the N. So for present value, remember the numerator is 1 minus V to N. For accumulated value, the numerator is 1 plus I to the N minus 1. So this is the first tips. This is the first tip, and it should apply for only level annuities. Level annuities mean all payments are equal. Next lesson, we are going to learn an annuity in which the payment are increasing or decreasing. So for level annuities, the numerator is 1 minus V to the N. The denominator is told by the symbol. So if it's divided by I, you understand this is an annuity immediate. If it's divided by D, you understand it's annuity due. So D mean due, I mean immediate. If the payments are make M times is period, the denominator is I to the top script M or D to the top script M. Remember, this is nominal rate of interest. So the nominal rate of interest or the discount rate of interest is basically the nominal rate of interest, and the nominal rate of discount is basically that the interest make compounded M times a year. So it's applied for the annuity with M times payment in each period. So for annuity immediate, in which we have M times payment in each year, we are going to use I to the top script M. For annuity due, we use D to the top script M, D to the upper M. Tip number 4, for continuous payments, we change the denominator to delta. So we're not going to use I or D, but we use delta. So I for immediate, D for due, and delta is for continuous. And the last tip is of the accumulated value for level annuities have the same numerator 1 plus I to the N minus 1. So by using these 5 tips, you will find it's easier to memorize annuity formulas. So after I finish annuity, I'm gonna make a summarized table for annuity formulas. Now we have in annuities, when the interest varies, we have a trap that many people got it wrong all the time. So here's an example. Given the accumulated function A of t is 1 plus 0.04 t squared, calculate the accumulated value at time 5 of 5 deposits of 1 at times 1, 2, 3, 4, and 5. So imagine it's just simply like at time 1 you deposit 1, at time 2 you deposit another 1, at time 3 you deposit another $1, at time 4 you deposit another $1, at time 5 you deposit the last $1. And the question asks to find the accumulated value at time 5. So many people will got this one wrong. Like some people will approach this problem using accumulate value as A1 plus A2 plus A3 plus A4 plus 1. This is completely wrong because $1, the first $1 is deposited at time 1, not time 0. The second $1 is deposited at time 2, not at time 0. So you cannot use these formulas. The right solution is 1 plus a to the 5th over a to the 4th plus a to the 5th over a of 5 over a of 4 plus a of 5 over a of 3 plus a of 5 over a of 2 plus a of 5 over a of 1. The reason is the first $1 at time 1, we are going to bring it to time 0 first before we bring to time 5. So $1 at time 1, bring to time 0, we divide by 8 of 1. So it's 1 over a of 1. Then time a of 5 to have the future value. So that is the last term. So the last term represents for $1, deposited at time 1. Then similar for $1 at time 2. So we divide by a of 2 to bring it to time 0, and then time 8 of 5 to have the accumulated value at time 5. And similarly, similar for $1 time 3, time 4, and time 5. Another way to look at this problem, because it might be hard for you to imagine what's going on with the function, why we have a5 over a4, a5 over a3, and so on. So another way to look at this problem is using force of interest rate. So remember on the fourth lesson when we learned about measurement of interest, we learned how to compute the force of interest rate. So the force of interest rate is the ratio between the derivative of the accumulation function over the accumulating function. So it's 0.08t over 1 plus 0.04t squared. So we have the integral from t to 5 delta t dt represent for how money that is deposited at time t accumulated at time 5. So that becomes natural of a5 over at. So here we have $1 invested at time 1, then $1 invested at time 2, $1 deposited at time 3, time 4, and time 5. So for the first $1, the accumulating the formula to calculate the accumulated value at time 5 is e to the integral from 1 to 5 of delta t dt, and similar for the last 4 terms. So using this, we have accumulated value A is a5 over a5 plus a5 over a4 plus a5 over a3 plus a5 over a2 plus a5 over a1, and this is exactly the right solution right here. So remember this trap, like if the money is not deposited at time 0, you have to be careful. If the money is deposited at time 0, the problem is very easy. We have nothing to talk about. But here, the money is not deposited at time 0, but time 1, 2, 3, 4, and 5. So we really have to look at the ratio. We really have to look at the ratio. Next. So that is everything about continuous annuities. Now we are going to work on some problems, and next class Emma continue to finish annuity because we have only one more lesson in annuity, then we finish with annuity. So next lesson Emma go over increase in annuity, decrease in annuity. So let's look at the third problem. You are given um, a continuous annuity of n-year periods is 7.52. The derivative with respect to delta of this annuity is NIP 33.865, and the question asks you to calculate delta. So first of all, just write out the formula for continuous annuity. So A bar 10 is 1 minus v to the 10 over delta. This is using continuous annuity formula. And remember, v to the t is 1 plus I to the negative t, so that's e to the negative delta t. So t here 10, so we have 1 minus e to the negative 10 delta. This is from the first lesson, measurement of interest. So here we have, this is the formula of continuous annuity in terms of delta. So from here we have e to the negative 10 delta is 1 minus 7.52 delta. And we are going to differentiate this formula with respect to delta, because the second information talking about the derivative with respect to delta. So we differentiate this formula with respect to delta. This is just quotient rule, right? This is quotient rule. So numerator derivative become 10 e to the negative 10 delta time with the denominator delta minus the derivative, the denominator. So delta derivative is 1 time with the numerator is 1 minus e to the negative 10 delta, and the denominator we square the denominator. So from here, because we want to solve for delta, so we don't want e to the negative 10 delta here, so we are going to substitute this quantity replaced for e to the negative 10 delta. So we have 10 times 1 minus 7.52 delta times delta minus 7.52 delta divided by delta square. So this becomes 2.48 delta minus 75.2 delta square over delta square. So that's 2.48 over delta minus 75.2, and this is 33 over 865. So this is a very easy equation, right? So we solve for delta. So delta is 0.0599. So we round it up to 0.0060. So the answer is B. Next problem. You are given delta t is 1 over 1 plus t for 0 less than or equal to t less than or equal to 5, and we have to calculate the accumulated value of an annuity emitted S5. So S5 is basically you have to calculate the accumulated value of 5 payments deposited at time 1, 2, 3, 4, and 5. So remember, these deposits are not made at time 0. So remember the trap. Remember the trap that about accumulated value. So for this one, first of all, I'm going to use the force of interest rate to calculate the accumulation function. So A of t is e to the integral from 0 to t of delta r dr, and this is 1 plus t. This is a very basic calculus 2, calculus 1 and 2. Next, I'm going to use the formulas A of 5 over A of 5 plus A of 5 over A of 4 plus A of 5 over A of 3 plus A of 5 over A of 2 plus A of 5 over A of 1, and this become 8.7. So one more time, whenever you have problems in which the payment is not made at time 0, money are not deposited at time 0, so be careful. Like there is a trap, so you have to get rid of the trap. Problem number 3, given the information below, find S bar of 1. We're given a double dot n plus 3 is 13.9870 and S double dot n plus 1 is 23.6914. So we're going to find this. Here's the thing. You see, like, we have double dot cancel. However, uh, the the duration of the two annuity are not the same. One is n plus 3 and one is n plus 1. So we have to find a way to bring them to the time n plus 2. So remember, when we learn about annuity due, we have a connection between annuity due and annuity immediate. So a double dot n plus 3 is 1 plus a n plus 2. So from here we are able to find annuity immediate of n plus 2 years, n plus 2 payments. And similarly for accumulated value of annuity due, we have S double dot of S double dot n plus 1 is S n plus 2 minus 1. So S n plus 2 is 24.6914. So now we are going to consider the ratio of the two, because we are going to cancel I with I. So S n plus 2 over a n plus 2 is 1 plus I to the n plus 2 minus 1 over 1 minus v to the n plus 2, and this is 1 plus I to the n plus 2. Another way to think about it is just like Sn plus 2 is the accumulated value at time n plus 2. An plus 2 is the present value at time 0. So to bring us something from time 0 to time n plus 2, you multiply 1 plus I to the n plus 2. That's why when you take the ratio, it's become 1 plus I to the n plus 2. So here we have 1 plus I to the n plus 2 is 1.990 or 1240. So we use this, plug into either an plus 2 or Sn plus 2 to find I. So we have I is 1 plus I to the n plus 2 minus 1 over Sn plus 2. So I is 0.0365. But the question is not asking about I, it's asking about the continuous annuity, the accumulated value of continuous annuity. So S1 bar is I over delta S1. This is by the formulas of continuous, the connection between continuous annuities and regular annuity. So remember, S1 is basically just 1 because it's just like $1 at time 1 accumulated to time 1. So S of 1 basically, which is, I write S of 1 to make sure you can understand why we have I over delta. But S of 1 here is it's just 1. I is 0.0365, and remember delta is natural log of 1 plus I, so this becomes 1.0181. So where's 1? It should be E. The answer is E, 1.0175 or more. Next, problem number 4. You are given the integral from 0 to n of a continuous annuity a bar t dt is 100. Calculate the continuous annuity a n bar. So remember, continuous annuity, using the formulas, we have a bar t is 1 minus v to the t over delta. So we are going to integrate this quantity. So 100 is integral from 0 to n of 1 minus v to the t over delta dt. And here v to the t, we bring 1 over delta outside because it's just constants. And the antiderivative of 1 is t. The antiderivative of v to the t is v to the t over natural of v. And we take from 0 to n. So this becomes 1 over delta times n minus v to the n over natural of v plus 1 over natural of v. And um, 1 minus v to the n, uh, and this is equal to a bar n. So we have this is equal to 100. So we can find a bar n, which is n minus 100 delta. So that is problem number 4. Problem number 5, the last problem. You're given for interest rate I, a double dot n is 8.0336, a double dot to n is 12.8537, and the question asks you to calculate I. So don't forget double dot cancel. Usually when you see we have n and you have 2n, you think about quadratic equation, because v to the 2n is v to the n whole square. So whenever you see something like annuity 2n and n, think about quadratic equation. So we are going to take the ratio a double dot to n over a double dot n is 1 minus v to the 2n over 1 minus v to the n, and this is equal to 1.5999, which is 1.6. So rewrite as we have a quadratic formulas. V to the 2n minus 1.6, v to the n plus 0.6 is 0. And from here, we have v to the n is 0.6, and we are going to plug it in a double dot n to find d. This is a new to do, so we need to find d before we find I. So d is 1 minus v to the n over a double dot n, so which this is 0.04979. And I, remember I is d over 1 minus d, so I is 0.05239. So the answer is D, 5.24%. So that is everything of today. Thank you so much for watching, and I hope you guys enjoyed my video. So we have only one more lesson in annuities, that is increase in annuity and decrease in annuity. Then I'm gonna move to the next topics. Thank you so much. See you next time. Bye.